Types of matrices. Since matrix is just a form of rows and columns, that is the arrangement of numbers, values, content in the form of rows and columns are known as or is known as matrices. Okay, so just remember table whenever you are talking about matrices, because matrix are nothing but a table in the form of rows and columns. The number are arranged. So there can be different types of matrices. It depends on how the formation of table is, what are the contents inside the table is. The first one is a rectangular matrix. The rectangular is the rows and the columns, that is the horizontal and the vertical. These, the rows and columns are not same, because number of rows I'm writing n, number of columns I'm writing m. So this is the order of the matrix or the dimension of matrix. When this n is not equal to m, they are not similar, they are not same. This is the row, this is the column. So when the rows and columns are unequal, then we call this kind of matrix as the rectangular matrix. So we have two rows here, 1 2 3 columns here. So you can very well write the dimension or the order 2 into 3, that is they are not same. This is a rectangular matrix. Now, square matrix is a special form of rectangular matrix where the row and column are same. That is, if n is equal to m, then we call this matrix as square matrix. So you see 1 2 3 rows, 1 2 3 column. So we have 3 rows and 3 columns. So that is why it is a square matrix. Square matrix, all sides are equal. A square is a shape with all sides equal. Now, coming to the diagonal matrix. Okay. So when we draw this diagonal matrix has to be talked with the square matrix. So when we draw a diagonal in a square, all the elements which are coming onto that diagonal, those values are we are interested in. So diagonal matrix means all the values on the diagonal will have some value, otherwise it will not be. Rectangular matrix cannot have a diagonal. Okay, I showed you there will not be any diagonal. So in diagonal matrix, all the elements which are coming on the diagonal should have certain value. Other values should be 0 or will be 0. Okay. So this matrix I'm writing 2 0 0. Then this have to be 0. This is 4. This is 0 0 0 7. And now let me draw the diagonal. And this diagonal, all the values on the diagonal are numbers. Others are 0. That is why we call it as a diagonal matrix. Now, scalar matrix. Scalar matrix is a special type of diagonal matrix where the diagonal elements are same. All other elements are 0, the diagonals have some value, and all these values are same. They are exactly same. This is called the scalar matrix. So let me write one more scalar matrix for you apart from this example. Minus 10, 0, 0, 0, negative 10, 0, 0, 0, negative 10. So when you see this diagonal, all the values are negative 10. That means this is a scalar matrix. Row matrix. Now a matrix is consisting of rows and column, and the order can be written as n into m. So when we have a matrix with only one row, single row, we start calling that matrix as a row matrix. Only one row, row matrix. So the row we have fixed. When the row is fixed as 1, if I call n cross m matrix, n is 1 here. Now if we take a different view, the matrix can have only column without any row. Number of rows can be there, but columns is fixed. So when column is fixed, we'll start calling that matrix as column matrix. So row matrix, only one row. So when we say n cross m, n should always be 1. That is a row matrix. Column matrix, n cross m, the m should always be 1. Column should always be 1. This is a column matrix. Identity matrix. Now this is a special type of matrix, square matrix, with all the diagonal element should be 1. Should be 1. This is also a scalar matrix. Identity matrix is a scalar matrix also. It's a diagonal matrix. But it is a special kind of diagonal matrix where all the elements in the diagonal is 1. I'm making a 3 by 3 matrix. The example this shown is 2 by 2. I'm making 3 by 3. So 1 0 0 0 1 0 0 0 1. So you see all the diagonal elements are 1. And when you have all the diagonal element 1, other values are 0, then we start calling it as the identity matrix. Okay, this is the identity matrix. Okay, coming to the zero matrix. Zero matrix means, as the name suggests, all the elements has to be 0. That is, there will be no element other than 0. It can be 1 by 1 matrix, 2 by 2 matrix, or 3 by 3 matrix. So I'm making a 3 by 3 zero matrix. All elements, 3 rows, 3 columns, all elements are 0. This is a zero matrix. Upper triangular matrix and lower triangular matrix. Now the main thing comes here is the diagonal. Whenever we talk about upper and lower, it has to be first of all square matrix. Then only you will get a diagonal. And diagonal, the lower part and upper part, that decides it's a upper triangular matrix or lower triangular matrix. Upper triangular matrix, all the elements above and including the diagonal should be having some value. Others should be 0. That is, the upper part has some value, lower is 0. In the lower triangular matrix, the lower part will have certain value, this diagonal including, but the upper part will always be 0. Okay, so the upper triangular matrix, this is the matrix. Let me make another matrix, upper triangular matrix. So first we'll make a diagonal. Let me take a matrix of 3 by 3. So I made a diagonal. Now you have to write here number 5, 6, 9, any number. Other values below this diagonal will be 0. So you have to put 8, minus 10, any number. Now again, the lower part should be 0. So I'm making a triangle, proper triangle here. This is the upper triangle matrix because all these triangle part has value and the lower all are 0. So upper, that is why we call it as upper triangular matrix. Now let me write it as a lower triangular matrix. Again, making the diagonal, I have to put some value in the diagonal and the lower part need to have some value. Above values are 0. That is minus 8, 5, 6, any random number I am taking, 2, 3, 7. And all others upper should be 0. So this is the triangle, lower triangular. All values are there. The above part is all 0. We call it as a lower triangular matrix.